Okay. Hi, welcome to the Cloud Native Prague, and um, welcome to my talk about the Terraform provider, the custom Terraform provider, and Monorepos inside the Terraform. So basically, who I am, I'm Ondřej Šika. I'm DevOps engineer and consultant. I work as freelance, and I have a small DevOps company which provides a consultation and implementation of like Kubernetes and stuff around. And I also do lots of trainings. So if you're interested, we can talk about this later. So I don't have any slides at all. So I will go straight to the demo, and it's about a custom Terraform provider. I think you've heard about Terraform and how the Terraform works. It's been for quite a while, and my topic is how we can create a Terraform provider for our API or for some missing feature in the cloud, or basically if we want to work with anything with Terraform, and basically anything which has API can be controlled by Terraform. And the idea about the Terraform provider is quite good. There is a the Terraform basically does just a mapping of declarative objects into some imperative API. So basically, I can describe anything inside the Terraform as some declarative JSON-like structure. It's in HCL, and Terraform maps this on some API calls, which I can do pretty much with everything. So if my application, my backend, or whatever, my super cool cloud provider has some crude API like create, update, delete, and read, I can write a Terraform provider for that. Terraform just do the basic mapping, and all the functionality, which is cloud or the provider specific, sits in the own plugin. It's own binary. It's written mostly inside in Go, and we will create a provider for some simple custom cloud or something like that. I have some repositories here. I have also a links there in the presentations, but let's start with with our basic demo cloud provider, I've called it, and it's a super simple Python app. I can show you. I can show you here. In the GitHub. So here we have super simple application. I can zoom in. Yeah, and it's a Flask server. Sorry. It's in memory. So basically, the data are stored in SQLite, and we have two resources. We have some boxes, and we have some texts in those boxes. So I have some API example here. So basically, here we have a standard API. So we have a box. We can list those boxes. We can create a box using a put, and the box has just one name as a parameter. Then we can get a single box. We can update a box. Basically, we can update only the name of the box, and we can delete it. So basically, that's it about boxes. We can list all the texts inside the box, and same for the text. So basically, we can create a text inside the box, and it's super simple. I can run this server. Basically, I already run it. Just remove everything. It's docker remove all. It's run inside the Docker, and make run, which run the server. So basically, we have a server running on localhost port 8000. So let's see. The default route is, I think, down there, and it's super simple. just output of the everything which is in there. So all the boxes, all the texts, and I can show it here on localhost port 8000, and we see nothing, which is correct. There's nothing in there. It's freshly started, and I can also see it here inside a terminal window. I'll zoom the fonts a bit. Okay, so I will watch. This is just alias for watch, for some faster watch, and curl and SSL, and we see also nothing there. But we have those API, so we can create something there. So I have a query here, super simple post request, which creates a hello box, and I can call it on this API endpoint. So I'll copy this, the first one. Oh, so hard to copy it. Okay, maybe all together, doesn't matter. So I create a box, and inside the box I've created two texts. If I try to create the one text again, so I'll copy this one, and I will create a text, hello CNCF Prague. So it's created, cool. If I want to, for example, remove those first texts, I can also do something like this. We have some updates, so I can update them. It's just a put request, and if I want to delete the second one, just this. I don't need a data. I will just send a delete. So basically, we have some API which is working, and if I work with this, or if I have a CLI for it, it's a imperative approach to that API. And well, I don't want to do that. I want a Terraform provider which can work with this super simple API. So I have to start a new project. It's new Go project. I have one which is working. So I show you. I don't want to show you this one. I will create a new directory. We will go for everything right now. But if everything is messed up, I have one which is actually working. So, okay. So I'll go back from here and also from here. Oh, CD here. I will move this one here, and let's create a new Terraform provider. HashiCorp has a great SDK for it, and the idea behind those Terraform providers is the Terraform provider is own binary. It's executable, but it's not meant to be executed on their own. It's a wrapper around some functions which communicate with the target API of the target platform, and the Terraform run the provider that Terraform just exec this binary plugin. It creates a gRPC server, gRPC, and by the gRPC, it can communicate between Terraform and the plugin. So basically, that's it. Inside the plugin, you have everything you need to work with the target platform. Like if you have, for example, AWS or some large cloud, they probably have some Go library, so you can use that. In my case, there's no library at all, so I have to do everything by myself. So let's do that. The Terraform provider has to have name Terraform provider and the target name of the provider. So in my case, it will be demo, but if you go for GitHub, there is one demo provider already there. So this is basically the same thing I want to create right now, but this is like 3-year-old. So we will create basically this one from scratch. So I will create a demo 2 provider, which is basically the same. We will work with our demo cloud. Okay. So this is our API. And let's create a new provider. I'll create this one. So I'll go here. Maybe I close this these codes, and I'll create a new workspace here, and I'll go there. So basically here, cd Terraform provider demo. I don't want to create a Git repository yet. I will create a Go mod create and github.com Ondřej Šika, and this one. Go mod init, yeah. So basically, we have a Go project, set it up, and let's create some basics in Go. I don't want to spend much time on the common things, so I'll create some super simple git ignore. New one. I'll also increase like this. That's fine probably, and you can create a super simple git ignore and create something like this and demo 2. So that's it. So I'll create editor config. This is some company utils, so EC for Go, and let's create a editor config for Go. So basically we are good to start. And at first I have some API library prepared for it, so I can cheat a little bit. So I'll copy this and go here and download the basic API library. So this one contains some REST client for get APIs, post APIs, put and delete APIs. So the response is just a REST response, and this is a origin token and the path. And in this case, somebody for those post requests and put requests. Okay. We can try it. So I can try this. Go here, create a main Go. Put it here, and I can create a second terminal here and go run this module. We don't have a the rest here. Go mod tidy. You can see go sum is here. Some other dependencies is there, so we can try to run it. And you can see something is there, so we can work with the API. Okay, I have one more thing, and it's a API for those box and text. So basically, I can start with the box and create a box API, which is a list of functions. Here I can show you here we have some structs for the requests and responses, and we can use, for example, create box API. We just put a API origin token and the name of the box, and you can see here we will use our post API methods for creating a object and the response is a create box response, which is basically just ID of the box. Okay, so we can try this. So here, create box API, and in this case, the origin is correct. Token doesn't matter, but we have someone, and the name of the box will be Prague. Okay, let's start it. You can see the ID of the box is 2, and here we have a live view of the infrastructure, or at least something like it, and you can see, yeah, the box is there. If I want to delete it, instead of create, delete API, and here I have to put a ID, I think. Not delete API, delete box API, and here has to be a box ID. So basically, this one, you can see it has been deleted, and there's no box prop. So it's working, and let's start with the interesting part, and which is the Terraform provider. So I can download those 2 or maybe 3 files, this and the box one, and I'll show you what's there and how we can work with them. So here in the main, where's the main? Yeah, here. So the main is a bit changed. You can see the plugin serve, and we have some options there, and in here we are basically included our provider, and the provider is the entry point for the module. Basically, we don't want to have all the things inside of one large module package. So it's demo. I think it doesn't matter. And here we have a definition for the provider. The provider is a method which returns a schema of the provider here, and the schema contains a resource map. The map is for resources, for data sources, for everything you have inside the Terraform. So basically, for us, we have just resources. We can create also a data source there, but yeah, here we have a box and text resource. I will remove the text for now. There is also a schema. Schema is a configuration for the provider. So basically, we need some configuration. If you have, for example, AWS, you have some keys for AWS and a region and something like that. For us, it's just a API origin and token. So basically, the structure of the schema is API token. It's basically like the HCL you are writing if you using the Terraform natively. So here is a type. So the type is from schema types, and it's a type string, and if it's required. So basically, this required mean if I have to put it in every Terraform object or in all the setup of the Terraform provider. So yeah, the API origin is required, and the token is required as well. We have some configuration function which can create a configuration object. This is my code. So I create a super simple struct, and in the struct I store a API origin and the token. This is the method how I can get these the values from the schema, and I have to type it as a string, or here also as a string. So this is the configuration which I will use in the resources to communicate with the API, basically, which origin and the token for authorization. And here, if you see in the resource map, there is also a method which returns a resource, and you can see here we have also a schema resource, and there is a schema for our object. Basically, we have just name. So here is a name. We have a schema for the name, and also it's a type string, and it's required. So basically, that's it. And we have also functions here: create, update, read, delete. There can be, for example, import function to import the objects, the existing objects into the Terraform. So let's see the methods. So create method is here, and we have a method. We have resource data, which is the object from the schema, and we have some metadata here. And on that metadata, we have, for example, the config. So here, if I want to create a resource, I get all the schema values from it like this. So we have just name. I can put just name here, and basically, if I want to access the configuration for the provider, there is a config inside the metadata, so I can get a API token, API origin and token from the metadata here. I can call a create, and then I have just a response from my API. This is just my code or my library which communicate with the cloud, and then I have to write into Terraform state some data. So I have to set ID. The ID is required, and I can set everything else. So basically, if I don't set the name here, it's not a big trouble because the name is already there in the schema, because I have to create it with some name, and the name is inside the schema. But if I have something, some computed values or something which I receive from the cloud, like some other ID or something like that, or created time, whatever, I have to add it into schema like this, and it's returning just error. So basically, here we return nothing, and if the API call fails, we will return just error with some response from the API from the REST library. Same for every other method. So basically, read, I have just a object, and here I can read a ID. The ID is always string. There's no type for that ID. So basically, this ID is string. So here I have to convert it from integer to string, and here I have to convert it back from the string to integer. Call everything and set all the properties. This read is like for refresh state, something like that. There's nothing to be refreshed, but we have to implement that method. There's also update. So basically, in my case, it's very similar to create. So I'll call update and update the specific object, and the parameters, which is just name here, and the delete is super simple, just delete. So basically, that's it. We have just one object here, and it's very similar to the text, basically almost the same. So I will copy also the text one, like this. Oh, nothing. Okay. Yeah. And I'll try again. Okay, it's red. Well, I don't care. And yeah, you can see it's almost the same. We don't have a text API here, so I think we forgot this one. I can do them both together. So basically, you can see it's there, and everything's fine. I have to put the text here, copy what works. So cool. With our demo, just demo provider, I will create a demo 2. So basically just this. And I think I have to update the schema here. No, I think it will work. Okay, so let's try to build it. So go build. Go build. Okay, go mod tidy. You have to download the SDK. Cool. And okay. And go build, yeah. Now we've created a provider. It's demo, maybe because in the Go mod I have demo, not demo 2. Build again. Yeah, and we have a demo 2. That's cool. And if I try to run it, you'll see something like this. This is a binary plugin. It's not meant to be executed directly, and we can use this as a Terraform plugin. And how we can do that, it's a bit tricky. I think a few years back, it was super simple. If I want to execute this as a Terraform plugin, I just copied this into folder with all the Terraform modules and manifest, and that was it. But these days, it's a bit complicated because all the providers has to be downloaded or try to be downloaded from a Docker registry, not Docker registry, Terraform registry, which is at least it's a great way how we can distribute those providers inside the registry. I have a couple of my providers. I can sign in there and show you the providers profile, and you can see I have 4 providers here, and the publish process is not super easy, but it's not super hard. And I have a couple of own providers. There is some link for the GitHub repository. It's also obsolete, but we can very easily put our providers there. But it's not great for development because we don't want to release everything somewhere in the public. So it's quite tricky, but there is a way how we can run those locally built providers in our, for example, development environment. So I'll show you how. I will create a makefile, or I'll copy the makefile because I will I'll create a typos there in the path. So cp and makefile. Like this, makefile here, and you'll see here I will build the provider, and I will create a folder with the same structure as the Terraform plugin cache. So I have all my Terraform providers in home in basically on this URL. So I can show you the structure here. So basically it's a tree at Terraform plugin cache, and this is where I have all the Terraform providers on one place, and I can create something here in my demo. So if you see, for example, some provider for AWS, Terraform providers, Terraform plugin cache, Here is a registry, which is the official one. There is HashiCorp, AWS, and some versions. So for example, this one, and the platform and the binary. So if I try to run the binary, it's the same as I try to run mine. So basically, same output. It's Terraform plugin, not a executable. And I have to recreate this path inside my work there, or I can copy the Terraform provider on this path in my local cache. So I can create a new one. So in example, I will create a example source code there. So basically, I will build this using make. So make it, and I have a example folder with all the things here. So Terraform plugin cache local and so on. The local is like a registry Terraform IO. This is my local registry. It meant to be, I see it's for testing. It's not a production build, or it will not interfere with anything. There has to be some version. So for my testing, it's 0.0.1. It has to be at least one. This doesn't work. I tried, and there's not much documentation about this, but at least it worked. Okay, so basically I have provided there, and I will start creating a new Terraform sources here. I have one more thing I want to copy there, and it's a init. So examples also in makefile. So here I have to use a bit different Terraform init. So I have to use the plugin there from this folder. I don't want to use the global one. I want to use this one. And that's basically it. So let's create a simple Terraform file. So I'll create main.tf, and we have to create a Terraform required providers and my provider. In this case, it will be demo2, and the path is here, local Ondřej Šika demo2, and the version is 0.0.1. So demo2 is local Ondřej Šika demo2, and version is this one. So basically, if I hit a Terraform init, no, not this one, I'll go into example here. Oh. Yes. Now I have run this, and there's some trouble. Because it's not like this. It's a demo source and version. Yeah, it was copyable, I assume. Local Ondřej Šika a demo2, and version is 0.0.1. Yeah, that's it. You can see it has been successfully initialized. There is some warning about incomplete lock, because if I try to run this on Linux, there's no lock in the Terraform lock for Linux. I don't have a Linux binary, so I don't care right now. So let's work with the Terraform. So we have a provider, so now I can use a provider demo 2, and here I have to put what. Let's check the sources. We don't have any documentation. So provider, and there's API origin and token. So the token, we don't need any token, so I'll just use a API origin. You can see the recommendation is working because it's Terraform provider. It's a standard one, so I can use this one. So, and for me, it's HTTP 7001 port 8000. That's it. And if I try init it, there is what? Demo 2 should be one. Okay. Yeah, because it's not this init, but I think I break something. So try it again. Okay, doesn't work. Oh shit, yeah. Thank you. Okay, so I think the Terraform init would work. Yeah, okay, yeah. This is one without the plugin there. You can see it tried to connect to my local registry here, because this is the registry part of the URL. So okay, so I can try Terraform apply, and okay, record plugins are installed. So make work and apply, and you can see here the value of the token is required, so we have to provide it like you missed any required value inside a provider. So try something, but we don't want to do this. I will put a token here as well. Here. Okay, so if I hit Terraform apply, you can see everything is applied and everything's working, because yeah, there's everything applied because nothing is there. So let's create the first resource, and we have resources, and oh, I will lower this one. Resource, and you can see here we have to create a box at first, because we can put those texts in those boxes, and it can be proc or proc name will be proc, and that's basically it. So I'll switch into large terminal and show you all the stuff here. So basically cd Terraform provider demo example, and we can try it. Terraform plan, and you'll see the plan. Yeah, we will create this this object. Yeah, maybe this will be better, because if I go here, cd example, Terraform plan, you'll see the plan. You see the live output here, and if I try Terraform apply, I apply it, and we have a box here. If I want to delete it, Terraform destroy, and I will remove just this inside a Terraform. So it's basically same as I started. So we can put the proc there, and we can create two boxes, like resource demo 2 texts, and for example CNCF, and we have to connect the text with some box. So basically here is a box ID. I will disable the copilot for now, and okay, it's disabled but still working. Okay, box ID, taking about my computer. So I think this should work. Okay, at least I will trust this, and I try just this. I think there there's missing something important, but we will figure out. So Terraform applied again, and you can see there is a mandatory argument text. So we have to put the text here. We can also create a second box, like PyCon, for example, and try it again. You'll see 2 of them will be created. So hit yes, and you'll see it's there. If I want to update something, I will just update it like normal Terraform. So Cloud Native Prague, like this, Prague, and try this, and you will see standard update. We will call the update method. So I will hit yes, and you'll see it's there. So basically, we have everything we need here, but there is a second part, and it's about the publishing, the provider, and it's basically not that hard. There is some strict rule how we can publish the provider. So basically, if I want to publish this demo provider, I have to have a repository called Ondřej Šika on the GitHub /Terraform provider demo 2. I will show you this on some existing provider here, for example, on this post.io, which is some mail server. And basically, if boxes, domains, and some CFA results. Here, I have a Go releaser, which is a tool for building Go binaries. And here I have a couple of things. I have some platforms I want to build the plugins for, some architectures. I want to ignore alt max. There is a, I think, I'm not sure if the format, this format is required. Maybe it is. There has to be a checksum, and there has to be a signature for the binaries. So basically, that's required. I think this is the most trouble parts. If you run inside, for example, GitHub Actions or something like that, you have to have a GPG there, and you have to sign this. I don't release these things using CI. I will build them and sign them on my laptop. So I will just run this one. We can try it. So I can create a repository here. So git init, git at, maybe I will create a super simple readme, new file, readme md, Terraform provider demo 2, git at, maybe I want to create this one, so copy this. Download this one. We have to change a few things, like the name, maybe? No? Project name. I think everything's fine. Try to build it. So Go releaser. And we will just build. So build snapshot. I think it's working. So yeah, the names are correct. So basically it will work, I hope. So I will add everything. Yeah, git init, git. Maybe there's a dist, so I don't want to add a dist folder there. So here in the git ignore. I want to also ignore dist. I think it will work. So rm dist add everything again, commit it. It will be first version. I will tag it git tag v1 0 git push. Yeah, we don't have any repository here, so I will create a new one. GitHub new Terraform provider demo2. It will be public. Create. We will push everything. We have a master here, so push. Git push tags. Release it. Go releaser. I will release it. Go releaser. I have to source my GitHub token here. GitHub token and start it. So basically, we will release this. We will sign this, and then we can go here into publish provider, and it will browse all the connected repositories from the GitHub in the format like my Ondřej Šika Terraform provider something demo2. I have to wait until this will be done, and then I can add the provider for the Terraform register, and basically that's it. So yeah, there are some questions. Yeah, so thank you and questions, and there are some links for the sources.
So first we will start with the question in here. So my question. No, so I will continue with the Slido. So first question is how to handle errors and debug these providers.
Yeah, there is a the errors are handled like normal errors in Go. If I show you, or I have to put a password for here. I hope. Or maybe we will not sign it because I don't know the password for this key. Anyway, the question here, for example, go away. Here in the all APIs, I just throw errors here. There's also a in the sorry, not here, in here. If I open, for example, create, there is a just error as a return of that method. So basically, if I have an error there, I will send the error here, and the Terraform handle that. And for the logs, there is in the metadata there is a flag if the log level is if the log view and which log level is set, so I can print the log message. There is also logging thing in the Terraform, so I have to send all the logs there and basically log in their specific logger, and that's basically it.
Okay, there is another one. What is the fundamental difference between Terraform and Ansible in scope of using cloud modules, AWS, for example?
I think the basic difference between Terraform and Ansible is there's some overlap, but the Terraform is for infrastructure, and what Terraform does very well is this one. If I want to delete the infrastructure, if I want to remove something from infra, I will just remove it from the sources. So that's it. I will go back here, and I'll try it somewhere here. So example, and if I apply it again, you'll see something will be removed. I will remove, and it's gone. That's basically done by the state. Terraform has a state which remember everything which is created by Terraform, and by this I can remove very easily anything I've created by Terraform. Same for if I delete everything, you can see it's also delete the box. And in Ansible, I have to create a delete task for removing some parts of the Ansible manifest, which is not great for infrastructure, especially in cloud, when you will pay for everything. So if you keep some configuration file which you don't need it on the Linux machine, it's no big deal. If you keep some VMs or EC2s or Kubernetes clusters in AWS Azure, it's a big deal because it costs money. So basically, that's the key difference. Yeah.
As you said, the Terraform keeps all objects some are stored. Is that stored on the local machine? So
there is a mechanism where you can store that state. Basically, here it's stored in JSON file. If I apply it again, Terraform applied just alias. You'll see here cat Terraform tf state, and here is the state. But in production, you will have the state, for example, in S3 bucket or in GitLab or something like that. There's plenty of states backend. It's Terraform state backend. You can use Kubernetes for it. You can use Postgres. You can use Terraform Cloud, which is there some executor for Terraform as well. So basically, in the production, you have the state in some shared namespace.
Thank you.
So last slide of question: what languages can you use for provider creation?
You can use anything because the provider is executable. So basically, if the provider will be in the specific format, it can be written in Go, in Rust, in C, in anything. But most of the providers are written in Go because there is great SDK for it. You've seen it, and there is SDK for Python, but I think I never seen any provider for Terraform written in something else in the Go than in the Go. So basically, it's just Go. But in Terra, you can use anything.
Okay, thanks. So that's it. So is there any question in the audience? If not, so 3, 2, 1. Okay.
Okay.
So thank you, Ondřej.
Thank you as well, and